So good morning, I am Jerome Mouton. I will be doing a brief introduction before Fred Sauer. So I'm the co-founder and CTO at SnapEngage. We are an application on Google App Engine, a business application. And I'll just briefly tell you, how it's working for us and why we picked App Engine and how things have been going. So quick introduction on SnapEngage. We are a small widget that our customer place on their website, on their web application. And the main goal of the application is to allow your visitors to get in touch with you through live chat, through offline messages, to either report problem, ask for support, get some help during a sales cycle, or send some feedback. We integrate with instant messaging system. It's a real-time application. We integrate as well with some CRMs, help desk, bug tracker, stuff like Salesforce, Zendesk, Jira, Fogbuzz, and several other systems. So let's step back a little bit before we talk about App Engine. But I think we all remember the days when not so long ago, we had a project for a startup. We were putting together an application, and we were ready to go live. And to push our application live on the internet, we had to buy hardware. We were buying boxes, putting them in co-location, and we just had to make sure that everything was running all the time. We had to fix hard drives, we have to patch the OS. It was pretty much a nightmare, but that was the way of doing it. Scaling the application was tough as well. We had to put more hardware in place. Our life got a little bit easier back when hosting companies started to provide virtual servers. So at this point, we could defocus ourselves on the hardware. We just rented some virtual instances. We still had to do the OS administration. Oh, there's no slides. Sorry, I had my slides here, but if you can just come all around and we can maybe. So let me pause for 1 second while they fix the technical issues. I think we are good. All right. So let me scoot back to where I was about the co-location stuff. So again, it was past. I think most of us now are no longer in this state. Many of us are probably in this situation here. So we still rent these virtual servers, which is a big improvement. Our life is easier, but we still have to deal with scalability. We have to think about databases and making front end and caching and all these things. It's quite difficult. So when we got together with the team and we said, okay, we're going to launch this SnapEngage application, we clearly wanted to have a small technical team focused on the product, not having to focus on the servers and scalability issues. So it was one of key things. The other requirement we had, we were kind of old guys, so Java type of developers. So we wanted a platform that supported Java. So at this point, App Engine had both. It was a pretty good start. What was important, because we are a real-time application, and we cannot predict what will be the usage. It really depends on our customers' website traffics, which are aggregated. So we wanted the scalability to be a pain-free thing for us. Sorry. So same here. App Engine with the way they scale would make our life way easier than previous architecture. We knew our customer would be a worldwide user base, so we wanted to ensure that people from the US as well as from Asia, Europe, would have very low latency to our application. And that's another area where App Engine is very strong. Even though right now I think all the instances are running in the US, your customers get to your application through the Google network. So they have access point pretty much anywhere on the planet. People in Europe, maybe get in Berlin or maybe in Prague, and then they get their traffic routed on the Google network. It ensures you have low latency and very good bandwidth to the application. We also had some technical requirements. We knew we would like to have Memcache to make our application fast and reactive, but we didn't want to have to build our own cloud of Memcache servers. App Engine provides a Memcache service. We knew we'd have to process pictures. Our chat application allows to take screenshots of the browser of the user for support situations. So we have to upload these images, resize them, do some scaling and serving. App Engine has a pretty nice image processing API for that. We didn't want to reinvent the wheel. We wanted to make a tool that was based on standards, and we knew XMPP was the way to go for real-time communication. Same thing again, luckily for us, App Engine has a very nice XMPP stack and very good integration with Google Talks. So another quick example is task queues. When you interface with external services, many times you have to retry the HTTP requests. So like Salesforce, Zendesk have APIs, and when we talk to them, they may be down, they may be having some delays. So we didn't want to build our own retry infrastructure, and App Engine task queues is perfect for that and very efficient. So on the requirement standpoint, there was a very good match on what App Engine was offering and what we needed. Real-life data, it's working pretty well for us. We're still not a huge application, but we're seeing our requests per second exceeding 100 quite a lot during the week. Quick graph here of what we had in the past 2 days for the weekend. So it's working perfectly fine. Let me give you a quick anecdote before we move on. When we launched at the beginning, we had one customer one morning sending us a trouble ticket telling, oh, we are being featured on TV today in the US, so expect some increase of traffic from us in 30 minutes. So if we would have been on the classic infrastructure, trying to scale the application in 30 minutes would have been clearly impossible. With App Engine, we didn't have anything to do. We just seen our graph of utilization doing a spike about 10x in a few seconds, and it worked just fine. It was difficult for the customer in question because they had to answer all these chats in real time. But for us, it was just a breeze. The Google infrastructure did its job just fine. And I think for us, what was a 10x, for application was just peanuts for Google. But so that's a big benefit. Just a quick note: don't expect everything is perfect. There is still little gotchas. You will see sometimes the platform get a bit slower at time. What is great is they have such awesome technical team behind that. When they see something going wrong, it gets fixed so quickly. Your end user don't get impacted. Something that was a bit painful in the past, in the early first year of App Engine, they had to do regular downtime where they put the application in read-only to grow the infrastructure. The very good news is in the past few maintenance have been very short. They've been able to move them on weekends, not during weekdays. And even better than that, the next one upcoming for December has been canceled, which means they are making tremendous progress in having a platform this stable and working very well for us developers. Very quickly, let me summarize before Fred goes on the details of the platform. But that's, if you are starting a new company with a small team, want to be focused on your development, on your product, that's a dream platform. You develop, deploy, and it runs for you. It will scale. No patching, nothing like that to do. It's a dream for us developers. At this point, the platform is clearly mature and stable. We run an application which is a business application where people are paying for it. So that's still a small application, but it's a kind of a statement that it's working. So I wanted just to say thank you, Google, Fred, Pat, and everybody for providing such an awesome tool.
Well, thank you, Jerome. Let me just switch over to other slides for you and talk about some of the new features in Google App Engine. And while I do that, let me point out that there's another session after this about Google App Engine for Business, which you may be interested in, has some more details there. And there's a session about Google Storage, Prediction API, and some other cloud computing things. So watch that out. And then there's, of course, office hours. So that means some of the team members will sit on the couches, and we'd like you to come to us, show us your applications, bring us your questions, bring us the really hard questions so we get engaged there. Okay, so what's new in Google App Engine? Well, there's a few things that I want to talk to you today about. There are a few APIs that are new, and this is basically what's new since Google I/O. So every year in May, we have our biggest developer conference. And then throughout the rest of the year, we have in some key cities like Prague, we have Google Developer Day, where we kind of update you on the status and provide you some local sessions. So I want to talk to you about the Channel API, which is browser sockets kind of pushing content to the browser. The Mapper API, first step of MapReduce, some multi-tenancy capabilities. Matcher is a new high-performance query infrastructure, a little bit about the roadmap, and I have a SQL demo for you, since that's a new feature that we announced in May, and I thought I'd show it to you today. So I'd like to start with a quote, since we had a French speaker today. It's a French quote. You may be familiar with this one, which is, it seems that perfection is not when there's nothing more to add, but it's when there's nothing more to take away. This is common design principle when building something. Rather than add complexity and parts and features, you should remove features, remove parts until you have the essence left. And then you'll have something that's much more reliable and much more useful and can be used as a component to build other systems. And I think when Antoine wrote this, he was thinking just a little bit about App Engine. Maybe? So the Channel API, let's see if we can do this demo. And this will very much depend on network connection. So bear with me if this does not work. So this application is written in GWT, and it's a multiplayer game. Oh, I'm sorry, thank you. Let me show it to you. There we go. So we have, I signed in as Fred. Let's see if this works. No. We're out of the game. I'm sorry for that. Well, what I'll do for you instead is I'll dance. So in this game, you have Android, and he plays a game that we like to call Simon Says. So Andy raises his arm and then his other arm, and he lifts a leg. His hat kind of pops open, and each of the players in the game has to try to repeat what Andy has done. And all of this is synchronized via Memcache and communicated to the browsers via the Channel API. So it's a fun game you can play with just a few players. There's some sample source code you can download to see what it looks like. And if you do something wrong, Andy gets really sad. His antennas droop down and tears come down his eyes. So I'm sorry I couldn't share that to you. So the Channel API is asynchronous server-client communication. It's based on channels. Each channel has a name. So you set up a named connection between your users and the server. It's bidirectional. So the cool feature is that you can go from the server down to the client, but it's bidirectional, so you can also send from the client to the server. On the server side, you send messages via channel service object, and then you receive your messages in a little webhook. On the client, which is the interesting piece, we have a JavaScript library. So there's a script tag that you include on your web page, which provides all the plumbing, all the infrastructure for this channel service. And then you receive messages in a callback. This is the exact same infrastructure in our data centers that handles Google Talk. So if you chat in Google Talk, then you're using essentially the Channel API infrastructure. So this is what that interface looks like in the server. You just have 3 simple methods. You create a named channel, you send messages, and you can parse messages that you've received. So you can send, you can receive, you create channels. On the client, very similar, but looks a little bit different. So it's JavaScript. We first create a new channel. So the very first thing, even before this, is that script tag that you include on the page. But now, if you want to use it, create the channel, open up the channel that gives you a socket, and then you set up an on-open callback. So whenever, once the channel opens up and the socket's ready for communication, you'll receive a callback so you can set up the status and say online. Then every time there's a message from the server, this callback will be handled. So if that's an instant message, you can then display that in the user interface. And if you want to send something to the server, you just say socket.send and you pass in a message. So here's what the architecture looks like for this little demo, Dance Dance Robot. It's a Google Web Toolkit application. It does use some GWT RPC. It didn't really have to. It could have used the channel API, but this game was set up this way. That connects to a server, in this case App Engine, which has task queues for background processing. And then communication back down to the client happens via the channel API. Now on the App Engine, we need to persist some of the information. We need to keep track of state. From one player to another player, we have these sessions, these games, and so we have a couple of things we can use in App Engine. There is a data store that we can connect with, and Memcache. Memcache is kind of a temporary place to store some information. This game uses Memcache. And session state is persisted automatically to both the data store and Memcache. And that's how you keep track of a session across requests. Each request from a user may go to a different server. So you need a common place to get to the user data. That's the session data. And then we can store images in the blob store. So we have a nice little stack. We have Google Web Toolkit on the front end, written in Java. We have the server-side code on App Engine, also written in Java. And then we plug in the channel API to give us the connectivity and push. The next new, and I should mention that the channel API is not quite launched yet. You can play with it locally, but send me an email if you're interested in testing. You have a fun application to build, and maybe I can set up your application. You can start trying it. So the Mapper API, it's the first step in a full MapReduce story. And some of you probably know what MapReduce is, so maybe I should ask. How many people know what MapReduce is? Raise your hand. Quite a few. Okay, very, very impressive. For those of you that don't or want a little refresher, this is from Wikipedia. MapReduce is a framework for processing huge data sets. Think of crawling and indexing the web. You have downloaded a copy of every single web page and you want to build an index. You want to be able to find those web pages which contain the word prog in them. Now, you could just search through them each time you have a query, but that would take a very long time. So that's why you want to build an index so that you can quickly find these pages. So really, really large data sets. Of course, it works fine on small data sets as well. It works on certain kinds of distributable problems. These are problems that can be chopped up into smaller pieces. Think of, again, crawling the web. Each page can be handled separately. I can look for all the words prog on this web page, and I can, on a different machine, look at the word prog in another web page. I can do all of these tasks in parallel. So that problem is really well suited for MapReduce. MapReduce also uses a large number of computers to do this parallel processing. So let me just walk you through what that looks like. You start with your data sets on the left, and you can just imagine web pages here. So you have a large number of web pages, and for each web page, you're going to apply a function that does word counts, for example. This is called the map function. This is a function you write, and it's often only just a few lines of code. The input to your function is the text of the web page, and the output is a list of words and the number of occurrences. So prog appears 5 times. The appears 100 times. Google appears 1 time, and so on. The second phase is the important phase, and I like to call it the magic phase. It's the shuffle. It's taking perhaps billions of pieces of information and reorganizing them and shuffling them and putting them in order so that they're together. So on the left, you had results per web page. On the right side, you have web pages per result. So imagine that the blue box at the top is all those web pages that contain the word prog. So prog, 7 occurrences, this page. Prog, 12 occurrences, this other page, and so on. So you have a long list, but it's much, much shorter than the original list of websites. So you've, at this point, defined the map function, and then you've used the MapReduce magic to get to here. The second function that you write is called the reduce function. And the input to your reduce function is one of those result sets. So all the pages containing the word prog get input into your reduce function, and then you produce out of that an index. Maybe you put the page with the most occurrences at the top, and the page with the least occurrences at the bottom. And then you output in that some reasonable format. You say prog, and then you list a number of websites in order. Again, that reduce function, just like the map function, is probably fairly simple. It can be 1 or 2 lines of code, it can be 20, 40 lines of code, but it's usually a little bit. And you can do amazing things with this. You can take a very large data set, and as long as the problem can be parallelized and chopped up into pieces, you can write a very simple function to map over the data, let the infrastructure do the shuffle, write a simple function for reduce, and you can get your results. The Mapper API is concerned with that first step, the map. So you can take any of your entities in App Engine, any of your kinds. So imagine all of your customers, or all of the orders, or all of the sales data for your system, or all the logs for your website. And you can map over them. You can perform a function for every single entity, and you can perform it for many entities in parallel. So this is batch processing at scale. Sample use cases are report generation. You can summarize data. You can group data. You can do exports. You can migrate data over to an on-premise system and back it up. You can do schema migration. So you might have customers stored in your database in one way, but you've decided that you want a different set of entities to store your customer. Maybe you're adding some fields and properties. Maybe you're combining order details with order headers, or maybe you're separating them out. And you want to go through your entire data store of all million customers, 100 customers, billion customers, map over them and have them all be updated. It's built on task queues. So if you've used App Engine, you know the task queues are the way to run things in the background. They come into your application just like web requests, and the more task queues you create, or the more requests that come into your application, the more instances of your application that we spin up automatically for you. And then when your requests are finished, or your tasks are finished, we spin down those requests. So we automatically scale up and scale down depending on the workload that you put in App Engine. The mapper is rate configurable, so if you don't want to burn through all of your quota in a few minutes, but rather like to spread it out over the day, we can do that. Or if you'd like to go really, really fast, that's possible as well. The mapper is an open source project. It's based on the Apache 2 license. You can download the source code from mapreduce.appspot.com. And of course that means, if it's open source, it means patches welcome. So if you have features, you have bugs, you have patches, please send them, and we hope to get them incorporated and make it better. The mapper was written entirely in user space. So there's no fancy secret App Engine sauce that runs in our servers. This was written as a project that you could have written, and that means you just take this project and you include it with your source code, and you can use the mapper. It's a servlet, it's some task queues, it's a bunch of code put together to make it easy for you to manage the task of creating all these tasks, spreading them out, sharding them across multiple workers, partitioning the work. There's both a Python and a Java version, so you can use whichever one you prefer. And as I said, automatic sharding or partitioning of the work, rate limiting. You get a special status servlet. There's a path for this, MapReduce servlet. And there's counters. So as you map over your data, you can keep track of things, how many successes, how many failures, or count customers are configured correctly or incorrectly, or whatever you want to do with counters. And you can batch data store operations. So you can have multiple commits of multiple changes to your data store going in as a single commit. And I'll show you some of these features in the demo in just a little bit. But let's jump to the multi-tenancy or Namespaces API. What we aim to do is provide a way for you to have many tenants, many customers on your App Engine application without having you to worry so much about separating and isolating the data from your different customers. So you're probably familiar with the way App Engine does things today. You have users running web browsers, or maybe it's APIs. They can be mobile users, can be desktop users. They come into App Engine and they hit the app servers. This is where your code runs. This is where your application runs. And then your application makes calls to the data store or Memcache for either temporary or permanent persistence. But as you add additional groups of users, you might find that you really have a need to isolate and separate out the data from those different groups. So all you have to do is, in Java land, create a filter. And this is a servlet filter. You define it globally for your application. And then in a couple of lines of code, you just say namespace manager.set, and you provide it a name. You get to pick what name it is and how you determine what that name is. You could pick the user's email address and separate the data for every single user. You can pick the user's domain name so that all users on company.com are here and othercompany.com are separated out. You can use something in the request header. You can do a lookup in the data store and decide where that user is based. Really easy. And as soon as you set the namespace, you've virtually created a number of separate data stores that are all logically separated from each other. Same thing with Memcache. Just as you set the namespace, and you magically have these separate instances. So Namespaces API, it's multi-tenancy. You can start with as little as 3 lines of code, or you can get much more complex than that. It's designed to be really lightweight. There is no construction cost. So to create a new namespace, you just use it. You don't have to say create namespace. You don't have to check if it exists. Just referencing the namespace will create it. Similarly, if you delete the last entry that exists in Memcache in the data store for that namespace, it's gone. There's 0 overhead, 0 construction cost. And that's because it's just a prefix. And I'll show you what that means in a second. It's built into the admin console. So when you're looking at the data store from the admin console, you can put in a namespace and look at just one compartment of data or another compartment. So let's look what those prefixes look like. If you're familiar with Memcache, you know that you can put in an arbitrary number of keys and values. And you can do lookups. You provide a key, and then Memcache will give you back the value that you put in there earlier, unless, of course, it's expired out of the cache. So let's just look at one of these entities. And now think about Memcache. We're not only implementing Memcache for your application and my application, but everyone's application. And it really wouldn't be very useful for us to create a separate Memcache machine or set of machines for every single application. We would very quickly run out of servers. We want to share the infrastructure so that my keys and your keys and everyone else's keys can live together. But it's very important that your keys and my keys don't get mixed up. So we have to isolate them from each other. So we have to do it logically. So what we do under the covers, if you look at our implementation, we actually simply prefix each of your keys with the app ID. The app ID is unique to you. You have a different app ID than I do have for my application. And so the real key in our Memcache is app ID plus your key. So now we've just magically created separation between all of your keys and all of my keys because there's an extra prefix. So this seems like a pretty neat trick. So let's move the app ID over and let's put the namespace inside of there. And look what we've done. We've just done the same thing. We've created a number of logical subdivisions inside of our app ID's namespace. So the real key that we store in Memcache when we're looking up your properties is your app ID plus the namespace that you provided plus the key that you provided to create a composite key that we use for the lookups. Now we do the exact same thing in the data store. Now, excuse me, these rows here in the composite indexes may not look that familiar. So if this is odd, I can highly recommend there's a talk at Google I/O in 2008 called Under the Covers of the App Engine Data Store. It goes into great detail and throughout the presentation builds out the 3 rows that you see here and explains how we do indexes on App Engine, how everything is built in Bigtable, what the keys and what the references look like. So if this is confusing, don't worry about it too much. It's very similar to the Memcache side of things. If we just look at the top row, you see that all of your entities in the App Engine Data Store are the kind, let's say customer or order, and then a key that you provide. So maybe customer and then 1, 2, 3, and then all the properties for the customer. Customer's first name, the customer's last name, contact information, etc. All of your entities are stored together in App Engine. So your customers, which start with the letter C, come first. Customers 1, 2, 3, then customer 1, 2, 4, then customer 1, 2, 5, and so on. And then later in the data store, you have your orders. Orders start with an O. O comes after C. So first all your customers, and then all your orders. Order number 1, order number 2. So that's great separation. Your customer data and your order data, they're separate, even though they're in one big table. Of course, in App Engine, you have apps, I have apps, and we need to separate those. So we do the same trick. We have the app ID in front of your key to create a logical separation between all the data that you own and all the data that I own. Of course, we can do the same trick as before. We can move over the app ID and then insert a namespace. And now we have logical division within your application. Now you'll notice that if we leave the namespace blank and don't put anything there, we have precisely the old keys, which means if you have the empty namespace, you get to see all your old data that's there today before you turned on namespaces. Now this is a convenient place to put global configuration data that's maybe shared across all applications, or it's a way to migrate. So you can start with the empty namespace and then slowly move customers to very specialized namespaces as you'd like to. You can also use this for testing. Maybe you have a test or pre-production namespace where you do some last-minute checks, and then a production namespace to be absolutely sure. Before we get to the demo, I want to talk to you about the Matcher API. This is a new API. It's, again, not quite available, but you can email us about it. There's, you can try it out in the Python version in the SDK and see how it works for you, and really love to kind of hear your use cases and see some great applications built on this. It's a high-performance document matching infrastructure. And the way this works is you define a number of queries that you want to perform first, and then you feed documents or entities through these queries. So it's a little bit different from the usual way of doing things. Normally, you would create all of your data out there, and then you want to run queries over that data. Find me all customers that have a last name Smith. Find me all customers that were born 10 years ago. But what if the data that you want to consume is data that's streaming at you. What if you're consuming a Twitter feed or a Buzz feed and want to, or web pages that are being built, or help desk tickets that people are entering. So that's why we have this query API where you define your queries first and then you feed data through it. So it's kind of like a filter. And this is what it looks like in Python. We define our model, which is just a regular data store entity. We have a few properties on it. This person has a name, a birth, and a length and height, or a height in meters. We generate our queries. So for example, we look for all people whose name is Smith or Schmidt. We're looking for all people that were born before 1900, and anyone who's taller than 2 meters. Then the next thing that we do is we presented documents. So these queries are registered with the system, and it's now ready. Every time you feed it a document, it's going to check that document against every single query that you've registered. So we create a person, and then we call matcher.match. And this will evaluate all the queries that I've registered against that document very quickly. If there's a match, the Matcher API will create a task in App Engine for our application, and it will send it to a special URL, this _ah.matcher. And so if you feed it a large number of documents very quickly, it may produce a very large number of matches in the task queue. You can process those in parallel, and you can imagine that you can go through a very large amount of data in a short period of time and very efficiently find the answers to some of your questions. So let's jump over to SQL, and we're getting very close to the demo now. This is the familiar picture from before, users browsing to your app, but we've added a SQL Datastore. We not only have Memcache and the data store, but we have a SQL database. Now, how do you use SQL? Well, in Java, it's quite simple. It's the same as any JDBC database that you would access from a servlet. You create your connection. You then create a database if you're using it for the first time. You create a table, and then you can insert into the table. Of course, you can select from the table. And that's it. You've just accessed the database and used it for the first time. So there's nothing special here. This is all standard JDBC stuff. Now, for those of you that follow along in the admin console, you may notice that from time to time there's new features that sneak in there that you may have not noticed. We try to announce at least the most important ones on the App Engine blog, but even some of the smaller changes might sneak through. So I would just want to highlight a couple of things. We have a new feature that's been out for a while, actually, that is custom admin pages. So many of you, when you build your applications, you have administrative screens that only you can get to. And it's to configure certain things in the application. It's maybe to enable users. And so you end up, on a day-to-day basis, having two web pages open. You have the App Engine admin console, where you're looking at traffic and maybe entering billing details. And then you have your admin pages where you're configuring users. And we thought, wouldn't it be great if you could take your pages and then put them in the admin console? And so that's what is available right here. Within your App Engine web XML, you can just define which URLs are custom admin pages, and we'll include those automatically right here on the left-hand side. And so you can see I have a Fred MR page. That's Fred's MapReduce page. And of course, your app can be very different. On the admin console, we have a new tab called the Instances console. This is where you can see how many instances of the App Engine, of the app servers, are currently serving your application. This is useful if you want to better understand how the App Engine infrastructure works, how we spin up instances. You can see the request latency per server. You can see the QPS, the traffic per server. And then in task queues, we have a few enhancements like being able to run tasks immediately and force them to happen. Also, there is a local SDK. So when you're developing your application locally and building things, many of you might not know that you can go to /_AH-admin, and you get a screen that looks like this. So you can interact with the local data store that's just on your development machine. You can, on the Python version, you can look at Memcache. You can do test XMPP messages in inbound email. So demo time. Finally. Let's see here. How's that? Let's make the internet's working. Good. Okay. So I built a little application here in GWT. On the left-hand side, you see the familiar data store. And I've created a little text box where I can enter queries and send them to App Engine. So if I click Go, it contacts the server, and it says, well, there's no entities customer, there's no agreements, and there's no usage. On the right-hand side, I've done the same thing, but I've done it with SQL on App Engine. You can enter the same queries. In this case, the tables don't exist. So you see the error messages or the results are a little bit different. Now, what are some fun things we can do in App Engine? I have some sample SQL code behind this button, so let's try this out. Right here, I'm just creating a table, a customer table with an ID and a name. And then I insert a row. My first row is Bob. Just for fun, I try to insert Bob again. Of course, there's a primary key, so that means that's going to fail. So, and go ahead and insert 2 more customers. Then I have a few rows for my agreements. And then the real thing we want to do on SQL is, of course, join our tables together. So here we've joined together customer and agreement table to produce the rates that each of our customer pays. There's still nothing in customer usage. So now, one of the practical things that comes up is you often have a need for both the scalable data store to handle kind of your high volume of traffic. At the same time, you have a need to perform relational queries. You are maybe used to the relational model. Maybe you have existing software or tools that you want to use, existing expertise. So part of your application, it may make sense to use SQL. The other part of your application, you're forced to use something that scales much better than SQL. So wouldn't it be great if you could use both? So imagine that in the data store, we have some usage. I'm going to just generate some random usage for our customers here. So I have 20 rows created. Let me do that a few more times. And imagine that all these customers are hitting my servers and they're generating usage, and I need to charge them for this data. So let's see what we have here. So we have 220 rows of usage data right now. Over on this side, though, SQL land, I have customers, I have agreements, but I have no usage data. And what I really want is to run a query like this. This is kind of a typical reporting query where I join a number of tables. I join my customer table with my agreements and my usage. I do a summary of the number of bytes they downloaded, the number of bytes they uploaded, and then I multiply the uploads and downloads by the rate that they've agreed to get a sum total amount so I can send them an invoice and they can pay me some money. Unfortunately, the customer data lives in the SQL database, and the usage data lives in the App Engine data store, where it has to live because I need the high volume and throughput. So what I really want to do is somehow combine the two. If I can't do that, maybe there's a way to migrate the data from one into the other, or maybe I can summarize the data. And so that's where the Mapper API comes in. So I'm going to show you that Mapper servlet that I talked about earlier. So this is part of the Mapper API, and I've defined a couple of mappers here. I have the test one that was in the sample code. I created a delete mapper, which is one I'll talk about in a moment. And I have the SQL migration mapper. And I'm just going to kick it off. And then I can drill into the details. I'll refresh the page, see when it gets started. There we go, we have a graph. Refresh again. There we go, so we have a number of workers, they're all doing work. And by default, I have 8 workers, and each one is processing a chunk of the work. And so I have 8 processes in parallel going through my 220 rows and inserting that into the SQL database. So let's go back here. And I'm going to take the same query from before, haven't changed a thing. I'm just going to press go. And if the data successfully migrated, then the customer usage table will now exist in the SQL land, and I'll be able to create my report. And there we go. So we've taken Datastore data, moved it over to the SQL side, then done our joins, and produced our customer report. So we get the scalability, and we get the flexibility at the same time. So that's pretty cool. So let me just show you kind of what that looks like. So on the server side, we have, let me show you the delete kind mapper. This is a pretty dumb mapper. I'm going to zoom in a little bit for you so you can actually see it. There's a few methods here, like a cleanup method that gets called for each context. There's a setup method. But the real interesting bit is the map function. I told you it'd just be a few lines of code. So here it looks like 3 lines, but actually the first and last one don't do anything interesting, so it's a 1-line map function. What the mapper API will do is it will call this method in my code for every single entity. So 220 times it's going to call this method. But it's not going to do them all in order sequentially. I've told it to do 8 in parallel. So it's going to divide up the work in roughly 1/8 pieces. And then each one of those workers is going to receive a number of rows and process that data. So it's going to pass in the key for the entity itself, and then a context. I'm going to log a message about the fact that I've just seen this key. And then I'm going to go to the data store and delete the key. That's the only useful thing I do here. So this mapper is great for getting rid of data very, very quickly. And then in the context, I add a counter. I say, well, this kind, I've deleted it one more time. So at the end, this counter should say 220. So let's see if that's the case. There we go. So customer usage migrated 220 rows. That's pretty good news. Let me show you the data migration mapper, which is a little bit more work, but not too much. Some of the same boilerplate code, but the mapper is a little bit more interesting. So I log a message. I have the entity and the key, and what I do is I get a list of properties from the data store. Then here I iterate over the properties, and I concatenate these 2 strings. So I have param list, sorry about that, and value list. And together, they produce this SQL statement. So here I have it, insert into customer usage. Then param list is a list of column names, retrieved dynamically. And then value list is a list of values, retrieved dynamically. And then I have a few lines of code to insert into the SQL database. I actually have some hackery there. The important statement is, let me find it, right here. Connection, create statement, execute update, and then SQL. And the SQL is that insert. So for each entity, I'm calling into the SQL database and say, insert into customer usage these columns, these values. And that gets called 220 times. To make it a little bit more robust for the demo and when I was playing around with things, I have some extra things here. So in this line of code, you see that I actually try to do the update. But if it fails and I catch a SQL exception, then I think, oh, well, it might be that I'm missing a column. So then I create this alter table statement. Add the column, try again, see what happens. This is more demo code. And then at the bottom I have here my migrated count. Here you see the setup method. So we're doing per worker setup. And what do I do here? I do the create table statement. This is the place where the table gets created the first time. And then per task setup, I actually just create a database connection. So each of my 8 workers has to have a separate JDBC connection to the database so that they can each process their work. There we go. So what you saw is the hosted SQL offering with relational queries on App Engine. You saw the Mapper API doing a Datastore migration from into SQL. You saw the Datastore, SQL, and Mapper all working together to build scalable reports. Custom admin pages. So let me tease you just about a few things that are new. We talked about some of this. But I did not mention high-performance image serving. So this is a new service associated with the Blob Store API. What you do is you take your images. Imagine you've taken a photograph here today, and you upload it to App Engine through the Blob Store API. And of course, we can feed that image right back to you. You can post it on a blog, or you can post it on your website, and we'll stream that image down to you. But maybe you have a version of your blog or your web application that needs to run on a mobile device. And you don't want to send down a 2 or 10 megabyte image. Maybe you want to send down just a little thumbnail that is big enough to fit on the screen. But each mobile device has a different screen size, so you need lots of different thumbnails. The high-performance image serving API takes care of that for you. You get a base URL, and you just append parameters to say, I would like this thumbnail in this size or that size. This is how I'd like it cropped. And the image API will take care of the thumbnailing for you and just serve the image automatically. So there's no code for you to write. You simply upload a blob, and then you change the URL, and we do the rest. We have OpenID and OAuth integration to give you more login options. I talked to you about custom error pages. We've increased the number of quotas, and we've gotten rid of all the 1,000 count limits. So if you look at some of the older App Engine blogs or articles or any discussions on the web, you'll often see this reference to, well, you can only query 1,000 entities or you can only count 1,000. All those limitations are gone, so you shouldn't worry about those anymore. And for those of you that build in languages on top of the JVM, so like JRuby and Groovy, you might find it a little bit annoying that you have to create this App Engine web.xml file just because you're using the Java version of App Engine. And so we've now given you the option of using the app.yaml, which is the Python version. It's a little easier to compose. It's much smaller, compact. And for those of you that aren't really programming in Java, but are using the Java virtual machine, this might be a really good option to quickly throw together a project. We can pause task queues now, and the dashboards show up to 30 days of traffic rather than the 7 days that we used to show. And of course, I really hope that you follow the App Engine blog. That's where we talk about a lot of these features and capabilities. And maybe you'll discover something new. So in the last 2.5 years, these are some of the highlights that I took out of the blog. I just walked through, and every time we had a release or an announcement or a change to a feature, I wrote it down here, and then I got rid of all the stuff that didn't fit on the slide. And then I just highlighted a few things. So you see that in April 2008, we announced the Python Java API, or Python version of App Engine. A year later, we did the Java launch. And a year after that, we announced App Engine for Business, which includes SQL and other support. And then just recently, we had the multi-tenancy capability added. Sorry about the time here, that's incorrect. But there is a session, App Engine for Business, that I think you should go to if you're interested in hearing more about those features. And Patrick and Simon should both be there to answer your questions. So that's it for this session. If you have any questions, I'm happy to take some now, or definitely come to the office hours and talk to us then. Thank you. Dziękuję.